a little bit about retro-commissioning. I won't tangent on this. I could talk about this for a couple hours on end. We do retro-commissioning very aggressively throughout the campus at CalTech. Now, we know that putting the WPT, the thermostats, in this building was a good idea. So I wasn't going to pay a retro-commissioning consultant to go to the zones, get a bunch of data for me down here when I know I'm putting those thermostats in. I'm going to hold that back, and I'm going to do it when I put the stats in at the same time. So let me show you what I mean by that. We have all kinds of data here in terms of branch pressure, the type of water flow we have, the pressure of the water, node IDs, and all kinds of things like that. And it all ties into the end device, which is the thermostat, linking the end device to what we call the control device. So a thermostat that controls a valve, and then we prove that it functions properly. And you do that through a whole building. Well, you can imagine if you're tuning up the building, this is a pretty effective way to do that. I'm not doing it twice, I'm doing it once, and I'm doing it when it actually matters because this is what controls it. So it's a good way to kind of save a lot of money in the studying of things. We're always trying to get better at how we study the buildings, get as lean and mean as we can, and then actually make it work right at the end of the day, and then codify it so that when we train the O&M staff later on the function of the new technology, they have a good guide so that they can walk away saying, yeah, I know how this building works. I know that you put in a thermostat on that node that had that branch pressure that controls that valve that actually is functioning properly because you proved it to me. So everyone okay still? Okay. So now a little bit about why it's more efficient, because it is about the data. An old pneumatic thermostat gives you whatever it gives you. And what I mean by that is you turn the dial to a certain temperature that you're hoping to get, and likely you'll get it within about 3 degrees. Some of the Honeywell guys will say 2 degrees, whatever. Probably true when they're new. The WPTs have what's called deadband capability. So getting a little bit into the nerd code here, but deadband simply means it's off. If you're within a low and a high temperature and you're in deadband, the system is at its most relaxed state. It's not heating or cooling or anything. It's just kind of floating. It's kind of like you're on the freeway and you put the clutch in. You're just kind of coasting with it. That's kind of the analogy. That's where the money savings comes in. So this is actually what an air handler might look like. So my goal is to make this thing coast as long as it possibly can. This is a lab building, so you can imagine that's kind of difficult because we have tight temperature and humidity requirements. Not impossible to make it coast. I like to make it coast as often as I can, because that means I'm saving as much of the utility as possible, and heating, cooling, and actually fan energy too. So it's not a magic trick to see where the energy comes from or where the energy usage is on an air handler. Dampers, fans, and coils. There's a lot of other parts on there, but in terms of the ones that actually cost you in the utilities, it's those pieces mostly. Filters a little bit. So we have data from the building. We can see it now. You saw in that system diagram that I'm taking the data, shoving it into the air handler now. I've shown you the pieces of the air handler that cost you money to operate. And now I'm showing you a trend of kind of a before and after, pre and post. This is a function of cooling energy as a function of temperature. The blue is the pre, the red's the post. And you can imagine, as I take the data and I make the system more optimized, there's a savings there. Because now the system has data to make more intelligent decisions. The sequence that runs the air handler is saying, I'm only going to give you as much as you need to satisfy all these thermostats that I can see now. Not a trivial amount of money to save by doing that. It wasn't difficult to put the thermostats in. In the library, like I said, it took us about 2 days to put them in. Put them in 2 days, program the air handler to see the data, and then do something like this. Optimize it with that feedback.